Hello YouTubers! Today we're going to be looking at this LED flag that is used in, I believe, on four-wheelers or quads for nighttime riding. It allows other four-wheelers or quads to see where you're at. It's kind of a safety item, I guess, for the sand dunes in Oklahoma. But anyway, you can see the flag here on the floor. It's about 4 feet tall, or roughly a meter and a half, something like that. And this bottom part here is where the controller goes, and that's what I'm going to be looking at today. You can see the individual LEDs there in the mast itself. It's kind of a flexible circuit board, and which makes perfect sense because you're going to be jumping and vibrating around all over the place on the four-wheeler. And but anyway. This here is the circuit board that I was asked to solder back on. The tactile buttons are on the back side. That's used for selecting the different modes of operation for the LEDs. This is the connector I was asked to solder back on, and apparently, there's 4 wires there for the 3 channels of LEDs, and then the power 12-volt wires are on the left side, and that connector will plug in like that, and the header will be soldered down there. But anyway, I got to looking at the circuit board, and I found out on the left side, bottom left side here coming up, that there's a zener diode that was broken. And apparently that happened during the removal process. I'm not sure of the complete history of this, but in the middle you have the microchip, or the MCU program part. It looks like the part number has been rubbed off of it, and then the IC just to the left of that is a serial EEPROM. And then at the bottom left there is the damaged zener diode, and that's kind of what I need to replace. In order to do that, I used a one that I had in my stock. It's only a 500 milliwatt, and here's the part number that I used. But anyway, I desoldered the existing MLF package on there and put I believe it was a SOD 123 package on in place of it. And you might ask how I knew this was a regulator or a zener diode. And typically this is what a regulator looks like for a board like this. It's you have a resistor and then a zener diode, and that drops the 12 volts down to 4.7 for the micro to operate, because micros don't typically run at 12 volts. In fact, I don't know of any that run at 12 volts. Anyway, I did record the desoldering and soldering of the new zener diode, which you can see a new one there in the bottom left. But unfortunately, my video skills are kind of bad, so it turned out very blurry and kind of boring. So I'll just cut to the chase here. I've heat shrink tubed, or put heat shrink tubing over the circuit board and soldered everything back together. And the 12-volt power lead you can see attached there. And whenever ground is attached to the bottom of the mast there, you can see the LEDs start cycling. And looks like everything's working good. I did let it run for a little while, and for the most part it was a good repair, I think. So we'll see. Have a good one.